do it. So because the software architecture changes dramatically, but the security models themselves do not, we have a real big problem. And we haven't learned from what we started to go down the path of service-oriented architecture, where things like XML security gateways and a whole bunch of other technology started to rear its head, but programmatically we didn't have the delivery models to actually make use of much of them. So as we move greenfield apps, which are new applications that are written specifically for cloud, that's one thing. As we move those, at the same point in time, we're really forced to think about really changing how we build survivable systems, because we can't depend on the provider. The provider does not care what's in your workload. It's not that they don't care. I say that wrong all the time. The provider, in many cases, doesn't have the visibility, and their service is not dependent upon knowing what it is you do. They're very single function. They provide you a maximally available platform to allow you to manage and deploy your virtual machines. What you transit, the data you transit with, or transit in, the applications, the operating systems, are for the most part irrelevant to them. So if you can't depend on them, you've got to focus on the things that matter most, right? Surprisingly enough, securing the VMs, the apps, and the data. So when we think about this, what this means practically is that you have to assume all of the environment, every piece of the environment, including the infrastructure you're operating on, is hostile. You cannot rely on that, right? Most of us think that way, but if in the enterprise, we kind of have this implicit thing of trust. Well, we're also the single tenant in those environments. When I move to an environment that has Coke and Pepsi, or my biggest competitor, or somebody who is out to get me, that doesn't necessarily scale the same way. You have to think that this isolation in memory, in terms of tenancy, will ultimately fail. That ultimately, whatever is providing the isolation will break. And if it breaks, what does that mean to your application and data? It means focusing on GEOS, just enough operating system, not the bloatware. It means trimming this stuff down and making it incredibly more hardened than we even do it in the enterprise today, especially when we compose these differential service levels. It means investing heavily in what I call entity management, not just human to machine, but machine to machine authentication with a lot of crypto. It means ensuring robust instrumentation and telemetry at all levels of the infrastructure. Right? It means choosing open protocols and stacks so you know how they function. You have transparency and visibility, and you have options. It means leveraging introspection so you can actually see what's going on. It means selecting platforms that enable robust monitoring. Okay? And in many cases, that monitoring is on you because you don't get it from the provider. It means utilizing what is called the 3 R's. And the 3 R's are some of you may not have heard of before, but it's a design philosophy that goes back quite a ways. It stands for resistance, recognition, and recovery. And it's the kind of the premise of survivable systems. And what it really talks about is that, again, I'm going to deliver my essential services even under degraded performance in the face of attack. It talks about resistance, the capability to repel attack. It talks about recognition, which is the ability to detect attack and essentially evaluate the extensive damage and communicate through secure data planes the fact that this stuff is happening at all tiers. It means ultimately that we have to recover. That not only am I going to be able to serve what I serve, the most critical part of my operations and my mission, but ultimately that I can limit the extent of further damage. Right? We don't think of these terms. Right? These seem like abstract, bizarre, military jargon that has no place in our lives because we don't have the technology, we're not organized this way. The reality is cloud makes you absolutely function this way. If you are not looking at your architecture in this way, it's going to be painful. Right? So when we kind of look at what this means, we've kind of gone from the infrastructure side of the world, we've looked at kind of protocols, we've looked at the underpinnings, we've looked at what kind of survivability means at a high level. What's very interesting is this return or this notion of information centricity in the middle of the hamster sine wave of pain. And what this really means is this kind of the center of the universe needs to return back to the thing that matters most to us anyway, which is the information. And I know this sounds like common sense and preaching, but the reality is we never get an opportunity to do this right. Cloud is that opportunity. And I implore you to kind of understand why, and how this can actually be a very good thing for us. So the Jericho Forum, almost at the same time that the folks at Carnegie Mellon started talking about their design philosophies, came up with their 10 commandments. I'm going to highlight them really quickly. It says, fundamentally, the scope and level of protection should be specific and appropriate to the asset at risk. Security mechanisms must be pervasive, simple, scalable, and easy to manage. You should assume context at your peril, meaning what works in one location may not work in another. Ultimately, devices and applications have to communicate using open, secure protocols. All devices must be capable of maintaining security policy on an untrusted network. Right? These were written before cloud came into play, but really was talking about how security has to evolve. The rest of them, all people, process, and technologies must essentially have a desired and transparent levels of trust. Mutual trust assurance has to be determinable, meaning I have to be able to understand what it is your requirements are. Authentication, authorization, accountability must operate outside of your locus of trust and control, which means I have to be able to establish trust. Access to data should be controlled by security attributes of the data itself. It must be self-describing. And ultimately, the data privacy and security requires segregation of duties and privileges. By default, data must be appropriately secured when stored in transit and in use. And ultimately, this notion of what they call deperimeterization, I think of it as reperimeterization, has been in play for years. Port 80 and 443 are a perfect illustration, right? We have no real perimeters anymore. So these 10 commandments have been around since, I think this was like 2005, right, when these things were first written. And they make more sense than ever. And when we think about these requirements, it's up to you to essentially go lay smackdown on vendors to support and build products that solve these problems instead of bringing out, necessarily, the shiniest, newest, greatest speeds and feeds of a product that isn't actually going to solve your long-term problems. So if you summarize this, information and data must be self-describing and ultimately allow it to be self-defending. The kind of Mission Impossible theme, right? This message will self-destruct in 30 seconds. Whether that data is structured or unstructured, the policies and controls must account for business context, which means we don't have to secure everything. We just need to secure the stuff that matters most. Information has to be protected as it moves between silos and in and out of these control perspectives, and the policies have to work consistently throughout various locations. And what that means is, without interoperability and portability in many cases, we're not going to be able to move that ball forward. So not only do you have to pressure security vendors, you have to pressure cloud providers to look at being able to describe and adopt standards that are open, that allow you to get solutions for which the third-party vendors can interoperate. Because it does no good to essentially say that a single source stack provider that can do all of this themselves is the only game in town, where what you actually need is the ability to move your data and content across multiple providers. So again, this comes down to threat modeling and risk assessment. It's not information alchemy. It's not rocket science. It's just a lot of crappy hard work. There's a lot of models you can use. Carnegie Mellon's Octave, RMI's FAIR, Microsoft's Stride Dread model for threat modeling. This stuff is out there. If you're not doing it already, then when you basically raise your hand saying we can't move to cloud, that's a problem, because you actually have no way of assessing or communicating why. So, the 6 key questions here are the ones you should be asking anyway for most assets. What happens if I get exposed? What does it mean to my business? What happens if could we be harmed if an employee of our cloud provider accessed the data? Would we be harmed if the process or function was manipulated, et cetera, et cetera? How do we deal with availability and resiliency issues? And the problem is, and Rich Mogul and I talk about this all the time, and I borrowed his information lifecycle model, which talks about, across the entire information lifecycle, from creation to storage to use to sharing to archival and ultimately destruction, this is a huge problem for us. We still have no real good tools, or we haven't had for a while, usable tools that allow us across this entire lifespan to essentially be able to enforce policy across the data. Now we're getting applications that at the time you create data, at least structured data, you have to input metadata before you can save it, which allows you to potentially start getting a leverage point on some of this. But I added discovery because trying to find this stuff, vis-a-vis the hamster sine wave of pain, is a real problem. You need every single one of these controls to essentially affect information-centric solutions. Especially in an environment, for example, that you don't own. But in many cases, these capabilities are not present in those systems. So it's like, what do you do? We have technology today that enable you, for example, if you wanted to start rolling your own, you could do and you could use. The problem is they're nascent, they cost a lot of money, and all of the agility, cost flexibility, and issues that you get when people read page 1 of the New York Times that say you're going to save billions of dollars by moving to cloud, you have to explain why you have to go buy the equal amount of dollars to invest in new technology to secure this stuff in the first place. That being said, there's labeling technology that, based on metadata, both in use, in flight, and at rest, can use labels to identify via metadata what data there is and ultimately how it should be protected. That's available today. You have technologies that got laughed at a couple of years ago. They've been around for a while. They're starting to mature, like data leakage, data loss prevention products that are starting to make their way into cloud-based platforms, both at the guest and the network level, depending upon your cloud provider. So DLP is a component. You have a wholly unpopular term in DRM, but for an enterprise, when you start thinking about digital rights management and how you basically tell something that this piece of data can be consumed for this period of time with these particular control requirements. EDRM there are platforms, operating systems, and applications that allow you to do that. You also have huge dependency on encryption today. So when you use most public cloud providers, they provide you, for example, storage capability. If you wish for that data to be encrypted, that's on you. You have to do that. You have to engineer it, which means issues that come back to the revenge of PKI. So if you haven't been going down the path of understanding how digital certificates and encryption are going to function outside of a normal VPN, that's going to bite you. But this technology, of course, encryption has been around for a long time, but as it relates to things like row and column-based encryption in databases and applications and peering between various tiers in these distributed application environments, encryption is a huge piece of this, right? Now we also have things like, then we have to deal with this notion of entity management and mapping that role-based and claims-based usage capability against an identity or even a machine-to-machine interaction. So identity access management, we have thousands of tools at our disposal, but again, they're not consistent. You have to roll your own. And then new things like tokenization. So for example, with PCI, this is a hot topic recently about substituting, instead of the real data, instead of storing actual credit card data, you're storing kind of tokens that represent that data. So you're not at risk, right? You're essentially of exposure of the actual raw data. You've got issues like data dispersion. So being able to chop up data streams, both in storage and in flight on the network, chop them up into individual packets, encrypt them, and then essentially make M of n number of packets reassemblable based on using encryption. So data dispersion is interesting because if you need to do things for BCPDR, or you need to make it use of essentially taking sets of network and or storage data and splitting them up so that they can't be accessed inappropriately, but then being able to recombine them on demand, data dispersion capabilities are very interesting. Mixes it into pools of streams of storage or data, but you can't essentially extract those sorts of those things holistically without being able to reassemble the keys. So stuff like this are solutions in the information-centric perspective that are available to you today. But again, if you look at this model, you have to figure out where you play and where those solutions are deployed. So if you don't demand solutions like that, or at least made available to you through APIs by your cloud provider, it's going to be real difficult for you to implement, because what that means is you're going to have to do it all on the guest, right? Which is incredibly costly, and that doesn't scale very well. So where does this take us? We need content analysis fully integrated in both productivity and what Rich calls transaction applications, as well as data stores. The writes have to be basically sprayed across these stacks, and the VMs at a very minimum have to describe what they need at the point of creation. The interesting thing, I was listening to the general of this keynote, this notion of choke points between kind of on-premise, off-premise, as well as application tiers or at the application VMs themselves, need to essentially enforce policies at the data level, not just at the VM level, right? We have to become information-centric, enforced by encryption and DRM. The rights transfer has to be able to move, because I need somebody else to make secondary reuse of that data and maintain it between state changes. You should not expect for quite a while most public cloud providers to do this for you. As I explained, they're mostly blind to your data, or at least should be. Right? That's what most people want. So a lot of it is on you, which is an issue. So are we there yet? Not quite. Right? This is very much a Lego blocks problem. So in the last minute or so, as I wrap up here, you're already here. Cloud computing is already happening. Will all your applications move to cloud computing, public cloud computing? Probably not, or at least not for a long time, which gives you the ability internally, if you start building and leveraging private clouds, to start getting a hold on being able to deploy technologies that work for you today. So we have to start thinking about fundamental changes in architecture, in programmatic management and security architectures that essentially wrap into this. We have to start thinking about centers of data, not data centers. It's kind of a funny little play on words, but it really means we have to build these survivable systems, and we have to start working on requiring vendors and cloud providers to give us visibility and transparency back to this data. The policies have to travel with the data and applications. Without that, it's useless. Ultimately, we have to allow the infrastructure to at least be made via telemetry, gain visibility and context through standards-based telemetry capabilities, right, and correlation. So if you think all the things like SIEM, you think about log correlation, you think about telemetry monitoring and management, these are all things that are just as consistently reasonable and needed today. So again, the key takeaways here, when I kind of outlined the distinction between different types across the spectrum of cloud providers, they're not all created equal. They're not essentially all built for the same reason, for the same people. And differentiation is really starting to crop up between being able to expose a lot of what this network